All right, guys, we're on section 5.2 today. It's the same scenario we had in 5.1 with Jim and the grass growing. So let's go ahead and get started. Because recall that Jim has a lawn service called Green's Grass Guaranteed. On every mowing job, Jim charges a fixed $30 fee to cover equipment and travel expenses, plus a $20 per hour labor charge. Work with your groups on items 1 through 14. We're going to work together. Number 1, on a recent mowing job, Jim worked 6 hours. What was his total charge for the job? Go ahead and figure that out. There's a $30 fee plus 20 per hour, and he works 6 hours. So that comes out to $150. Number 2, if Jim works for T hours, so it's not a specific number, it's just T this time, what will he charge for the mowing job? Write your answer as a cost function, where C of T is Jim's charge for T hours of work. So instead of plugging in 6, we don't know how many hours, it's just T hours. So that's $30 one time plus 20 per hour per time is kind of why they picked T here per hour. Okay, so this is going to be a really important function today, C of T. Make sure you understand that means you put in the hours and you get out the cost total. All right, it takes Jim 4 hours to mow 1 acre. Jim prepares a cost estimate for each customer based on the size, the number of acres of the property. The Apcon company is one of Jim's customers. The Apcon has 2 acres that needs mowing. How many hours does the job take? So it's 4 hours for 1 acre, and he has 2 acres. How long will that take? 8 hours. Another customer has A acres, so kind of like before, instead of 2, he has A acres. We're not sure, it could change depending on the job or the day. Write the equation of Jim's function. Write the equation of a function in terms of A for the number of hours T will take Jim to mow the property. The amount of time in terms of hours. How did I get 8? I took 4 hours times each acre, and there were 2, so 4 times 2. So this is going to be 4 hours times each acre. This is also another important function we're going to use today. We've talked about 2 so far. We have the cost function. I input the time, and that tells me what the total cost is. Where this function, I input the acres, and I get the total amount of time it will take me. How much will Jim charge Apcon to mow its property? Justify your answer. Go ahead and do that. Pause the video if you need. Your answer should be $190, and you should justify it. My justification would probably be something like this. If it's 30 plus 20 per hour, and I knew it took 8 hours, that's how I would show my work, and that comes out to $190. Sure, we have those 2 functions. We're going to need those from number 4 and from number 2. The functions in items 2 and 4 relate 3 quantities that vary based on the needs of Jim's customers. The size in acres A of the property, the time in hours T needed to perform the work, and the cost in dollars C of doing the work. Number 6, complete the table below to write by writing the rate of change of units and finding the slope of the graph of the function. So C of T, that's what we wrote in number 2. Go back and look. C of T equals 30 plus 20T. T of A, that's what we wrote in number 4. 4A. So what is the rate of change? Well, it's right here. It's what's associated with the variable here because it's a linear function. So it's that 20. So with units. So 20 what per what? $20 per hour. And then the next one is 4 is attached to the variable. So that's our slope because it's a linear function. So it's 4 what for what? For hours per acre. So the slope then is just 20 and 4. The rate of change is with the units. Number 7. Complete the table below by naming the measurement units, so dollars, hours, acres, time, units, for the domain and range of each function. So we've been working with these same two. So the cost function, that's the C of t. What is the domain? What's the input variable? The input is t. What's the unit on t? Time in hours. What's the output? What's I input t, time in hours? I output c. What does c stand for? The cost. What is the unit for cost? Dollars. Okay, you try the next part for t of a. My domain is A. What is the label on A? It's acres. When I input acres, I output T. What does T stand for? That gives me my time in hours. Calculating the cost to mow a lawn is a two-step process. You've seen that from what we did on the previous page. Complete the graphic organizer below by describing the input and output, including units for each part of the process. So we did a two-part or a two-step process. So let me flip back to kind of number 5. To get this answer, it was in 2 parts. We first had to figure out how much time it's going to take for that many acres. Once we know the time, that was part 1, then we can actually input that to find the cost. Those are the 2 steps. So our first step was to figure out, okay, based on his acres, how many hours will that take? After we figure out the hours, we say, okay, well, if it takes 8 hours, I can put in 8 hours for my time and get my total cost. The first thing I need is the acres. Let's go to our graphic organizer for number 8. The first thing I input is acres. Remember, this is our T of A function. When I put in acres, I get an output of hours. And then my next function, or part 2, the input is hours. And the output was dollars. Pause the video, make sure that this makes sense, why it's 2 parts and why it's in that order. This part right here is really important, which is going to talk about in just a second. If the output of this function is this input, that's a good thing. That means I can take these 2 steps and combine it into one formula. If the output of this function is the input of this function, I can combine them, and that's what we're about to do here. So it says the graphic organizer shows an operation of 2 functions called a composition. The function that results from using the output of the first function as the input for the second is a composite function. I think that was the title of our lesson today at 5.2. In this context, the composite function is formed by the time to mow function and the cost for a job function. Its domain is the input for the time function, and its range is the output from the cost function. So our input was acres, and when I combine it My input is acres, and my output is dollars. Let me go back, show you how I get that. We're going to do more work with it. If these match, I can go straight from here to here if I write my function correctly, because this will give me this will give me this, and that will give me that. Or these will be the same. So acres will give me hours, which I then put in for dollars. So we will be able to write one function instead of two. I'll show you how to do that, one function instead of two. When a composite function is formed, the function is often named to show the function used to create it. The cost to mo function, which we read C of T of A, is composed of the cost for a job, C of T, and the time to mow, T of A. The C of T of A notation implies that A was assigned a value in T of A by the time to mow function, then the resulting T of A was assigned a value, C of T of A, by the cost to mow function. So let's try to make sense of this. So to describe this function, stick with me, we haven't really done it yet. We're going to call this the cost to mow function. That would be a good description of what this function does for us. Tells us the cost to mow. The input, remember, is up here, acres. And you can always tell the initial input, it's the farthest right. That's my input, or my domain. And then the output is your farthest on the left, which is the cost in dollars. Okay. So we are turning two functions into one. This is how we write it. And this is the first input, and this is our final output. But how do we come up with this? This is on the next page. So let's sort of break this down. Maybe let me go back to this page here. You can just follow along. I'm looking at number 6 here where we have both of our functions. Remember, this function comes first. First, I need to know how many acres, and then that'll tell me the time. Once I know the time, then I can do this one. So imagine I had 30 plus 20t. Now, if I told you find C of 8, you would plug 8 in there. If I said find C of 10, you would plug 10 in there. That part you guys could do for any number of hours. But what if I said, instead of plugging in 10, well, I want you to plug in the previous function for A. Because remember, this is going to change depending on the day or the customer. So we're going to plug in, instead of a specific number, we're going to plug in that whole function for A. So then I can simplify this function now. 30 plus 20 times 4 is 80A. This is my function. It's my composite function. I put one function into the other function. So that's what's explained on question above number 11. Here is your original function. And it tells you over here what's happening. We're substituting T of A, because that tells me the time, into my other function. So my function, I'm supposed to plug time in here, but this function will give me time. So that's why we're plugging that in there. Normally this was just a T, but if I do the function T of A, my output will be time. So that's why we're putting T of A in right there. Okay, so that's why it's written as C of, what are we plugging in? We're plugging in T of A. Oops, one too many. We're plugging this function into this one. Number 11. Write a sentence to explain what the expression C of T of 2 represents. Include appropriate units in your explanation. So remember, this is acres. So I'm going to put in 2 acres, and I'm going to output the cost. So I would write down, it represents the cost to mow 2 acres. It represents the cost to mow 2 acres. Number 12, why might Jim want a single function to determine the cost of a job when he knows the total number of acres? You can pause it and write it for yourself. I would say Jim would rather do one function, C of T of A, than to do T of A, get an answer, and then plug that into C of T. Instead of doing this and getting, okay, it's going to take him 8 hours, and plugging in 8 hours, okay, it's going to get him $190. If we have one function that combines the two, which we came out to be 30 plus 80A, I can just plug in 8 acres Sorry, it wasn't 8 acres, it was originally 2 acres. It took 8 hours. So if I plug in my 2 acres here, I will end up getting 190. I would rather do one function, input acres, output cost, than to do 2 functions where I input acres. That tells me the time. And then I take the time, and that gives me the cost. I could do 2 functions for every customer every time I mow. That would take more time. Or I could combine it and do one function. Number 13, explain what C of T of 50 represents. This represents the cost it takes to mow 50 acres. The cost in dollars. You'll notice 14 is a little bit more tricky. What does this represent? C of T of A equals 50. So 50 is my output. Remember, I'm inputting acres, which we don't know how many, and my output is the cost. So we know that is 50. So this represents $50 to mow A acres. We don't know how many. Okay, the only thing I want to go back to is, again, how we make our composite function, which, let me give you a different one. So let's say I have A of B, and let's go with E of A. You don't have to write this down. I just wanted to re-explain it with a different example. Let's say that this function is linear. So let's say it's 5 plus 7b. Now, if I ask you to find A of 11 or A of 7 or A of 50, can we all do that? Yes, we can take this A function and we can plug in 11 here, or 7 or 50. We can plug in anything we want. Okay, I have another function. This is going to be, let's say, 6 plus 4a. So in this function, can we all find E of 7, E of 11, E of 50? Sure, we go to this E function, and it says to input 7 or 11 or 50, depending on the job. Now, I have 2 functions here. The input here is B, When I input B, what do I get? I get A. What happens down here? What's my input? It's A, and my output is E. If the output here matches the input here, I can combine these. I can input B and output E into one function. Here's the way I do that. So it's going to end up being input B, output E. So the way I do it is because this function happens first, this function goes into this function. So instead of plugging in A, we're going to plug this function into there. So instead of E of 50, plugging in 50 right here, we're going to plug in A of B. So it's going to be E of, you're not going to plug in a number, you're going to plug in a function. So E of 50 would have been 6 plus 4 times 50. This is going to be 6 plus 4 times, we don't have a number to plug in, like we had 50. We're plugging in a function. So we're plugging in 5 plus 7b. I would simplify that. Notice B is my input. I'm going to output E. This is kind of tricky. The word problem hopefully kind of helps us understand how the labels work and one function goes into the other. But we'll work more in section 5.3 on what we call this function composition or composite functions. But the gist of it is we take two functions, which we could do two functions every single time for every single customer. Or if the output of this function matches the input of this function, we can combine two functions into one, where the original input is the original and the output is our final output, which we have here. We input B, our output is E, and the way we combine them is the tricky part. You put the first function into the second function, wherever the variable is. Just like when you plug in 50 here or 11 here, you're plugging in this function here, which is what we did right here. 6 plus 4 times this function. Okay? All right, go ahead and try your homework.